In Lesson 9.3, you're looking at rotations. You'll learn to draw images using the angle of rotation and identify figures with rotational symmetry. How do some amusement rides illustrate rotations? In 1926, Herbert Sellner invented the tilt-a-whirl. Today, no carnival is complete without these cars that send riders tipping and spinning as they make their way around a circular track. The tilt-a-whirl provides an example of rotation. A rotation is a transformation that turns every point of a preimage through a specified angle and direction about a fixed point. The fixed point is called the center of rotation. In the figure, R is the center of rotation for the preimage ABCD. The measures of angles AR A prime and BR B prime, CR C prime, and DR D prime are equal. Any point P on the preimage ABCD has an image P prime on ABCD prime such that the measure of angle PR P prime is a constant measure. This is called the angle of rotation. For our first example, they gave us triangle DEF and asked us to draw the image of triangle DEF under a rotation of 150 degrees clockwise about the point -4, -2. So first, of course, we need to plot all of our points, connect the triangle. Next, we're going to draw a segment from G to point D and use a protractor to measure 115-degree angle clockwise with GD as one side. Then use a straight edge and draw segment array GR. We're going to repeat the process so we can copy points E and F. Finally, we'll take a straight edge and connect those points, and we have now rotated triangle DEF to D prime, E prime, F prime. When rotating a figure by reflecting it in two intersecting lines, there is a relationship between the angle of rotation and the angle formed by the intersecting lines. And that's stated in postulate 9.1. In a given rotation, if A is the preimage and A double prime is the image, and P is the center of rotation, then the measure of the angle of rotation, angle AP A double prime, is twice the measure of the acute or right angle formed by the intersecting lines of reflection. And so the corollary that follows directly from that, reflecting an image successfully in two perpendicular lines results in a 180-degree rotation. Find the image of the parallelogram WXYZ under reflections in line P and then line Q. So our yellow parallelogram is our original preimage, and if we reflect over line P, there's our X, Y, Z, and W. So one prime mark means it's our first reflection. That's the blue parallelogram. And then they want us to reflect it again in line Q, so now X double prime, W double prime, Z double prime, and Y double prime. So our final is the green with the double primes. The order in which we reflect a figure in two non-perpendicular intersecting lines produces rotations of the same degree measure, but one is clockwise and the other is counterclockwise. So order does matter. Some objects have rotational symmetry. If a figure can be rotated less than 360 degrees about a point so that the image and preimage are indistinguishable, then the figure has rotational symmetry. In the figure, the pentagon has rotational symmetry of order 5 because there are 5 rotations of less than 360, including 0 degrees, that produce an image indistinguishable from the original. The rotational symmetry has magnitude of 72 because 360 degrees divided by the order, in this case 5, produces the magnitude of the symmetry. Use the quilt by Judy Matheson shown below. Identify the order and magnitude of symmetry in the medium star directly to the left of the large star in the center of the quilt. Now, I'm not sure how they expected us to count that without blowing it up like I just did. But since I did blow it up, we can count, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 points on that star. That means our order is 16, and our magnitude is then going to be 360 divided by 16, which is 22.5. Okay, now they're getting a bit crazy. They want us to identify the order of magnitude of the symmetry in the tiny star above the medium star that we just did. Okay, let's make that bigger. It has 1, 2, 3, 4, 5, 6, 7, 8 points. So that means the order is 8, and the magnitude is 360 divided by 8, which is 45 degrees. A rotation turns each point in a figure through the same angle about a fixed point. An object has rotational symmetry when you can rotate it less than 360 degrees, and the pre-image and image are indistinguishable.